Okay, hello everybody. Today we're going to configure HSRP. Basically, hot standby routing protocol. What is it used for? It's mainly used for redundancy of the network, or to be precise, our one's dead. To be precise, it's used that just like this one. If one router fails, another router will pick up the load. That's the basic premise of the HSRP. Now, how do we configure that? How does it work? Now, basically, we have multiple routers in a network. Same network, it must be in the same network. Then, they will take turns. Yep, that's the right one. They will take turns or take responsibility depending on their situation. They could be in the standby or active. The active router will be the one administrating the routing in that network. While you can seem how do you put it like that so you can see it properly? No, I'll just adjust this one. Yep, start. While the other is just waiting or constantly checking if the other router is up and running. Just like what happened here. Now, I haven't actually configured the topology yet, but we are going to configure it right now. I have it ready, so we're just going to copy paste the basic topology. I'm going to show it to you while I'm doing it, so you can read it as well. So as you see, low logging console, no IP domain lookup, no service config, the usual. Low logging console means that we won't see the errors or what that's in it. We won't be needing it. It will be used in the show commands to troubleshoot anyway. So I have my hostname ISP. I have enabled the password. We're going to use secret. Our password will be pass. We're going to encrypt it per usual. Line console, we're going to add the password as well. Don't use pass. Same as with 014 and there. Do this with the rest of the routers. Oh crap. Router 1 is down. Oh, whatever, I'm just going to figure that later. Name is R2. Since router 1 is down, just going to delete that one and add another one. That happens when you are designing multiple and just turning them off and on like a maniac every time. So there we have it. I'm gonna move this here so you can see the topology. Yep, this should be fine. I'm going to start it and custom console. I'm going to connect it now. Going to copy and paste here. Yep, it's on. It didn't crash actually. That's what crashed. Whoa. And wait. Seems down. What the Control Z. Okay, we're going to choose the host name or one. And okay. After that, we're going to configure the routing and the IP addresses. I have it ready here. If you can see, this is for our ISP. We have 200.0.0 with 724 in the left, or fast Ethernet 10. In fast Ethernet 11, we have 201.0.0.0 subnet mask of 24. That's our networks. So for our ISP in F1/0, we have .2 for IP address. For F111, we have .2 as well. For R1 F1/0, we have .1. For R2 F1/1, we have .1. You can see the logic. Now we have 10.0.0.3/24 and 10.0.0.0/24 10.2/24 for R1 and R2 respectively. And for our default gateway, we have 10.0.0.1. Now this will not be configured directly via physical interface in our routers. You can, however, configure it via VLAN, which we will not do today because most of the time you will use VLAN in your company. And it's just a heads up that you can use interface VLAN for your HSRP. But in our case, we're going to be using the interfaces that are connected to the switches, which is gigabit 00 and gigabit 0, which is both gigabit 00. But for now, we are going to configure the IP addresses and the networks. So let's start with the ISP. Just going to copy paste it again. As you can see, interface fast Ethernet 1/0. We're going to now shut it, open it. We're going to add the IP address, which is 200.0.0.2. As you can see, it's right. And next it, interface fast 1.1, no IP address. Yeah. It's all the same. The difference here is interface loopback 0. Now, what is interface loopback 0 for? Interface loopback 0 is for testing, namely TCP/IP protocol. So it is on by default because you are going to use it by testing. You can look at it as well in your own desktop or laptop. What is your interface loopback? It is 127.0.0.1. But in the public network address, any host within the 127.0.0.0 network is a loopback. But for us, we're going to use the server disconnected with my. Okay, I'm gonna connect again. Sorry about that. Use my phone as a mic. Yes, you can do that. Technology. So no matter what happens, we can always ping, as long as our router is on, the interface loopback 0. That's its purpose. Testing. Also, it's a great way to test whether you have a virus infecting your desktop. We'll talk about it in a later video. So, what routing are we using? What routing protocol are we using? We are using router EIGRP 100, or source, destination, and the other one for 3. You can also use router EI1, but yeah, don't use it, bro. So network 00 for everything and no auto. Now, as you have noticed, we are using the old method, but the new method is fine as well. Actually, you should stick with the old method, but this is faster, so I'm using it. So let's do the same with the router 1. Just going to copy paste it. Now I'm doing this by shortcut, but you usually do this first because this is what you do. We are just making sure that our network is running. And lastly is interface .ft, which is copy R2, and there we have it. Finish. Let's all check. Show IP protocol. Yep, our gateways are fine. How about same as here? Yep. Oh, what? This is a problem sometimes, but as you can see, everything's fine. So let's show IP interface. No, show IP routes. You can see we're using Ethernet, EIGRP, the D. I'm not. Yep. D. As well. Yep. I'm showing you the network is now running. We're going to add some IPs to our host. Let's put 10.0.20. And for now, let's use the default addresses, default gateways for them. This is the PC1 connected here. Let's put a default address of that 3. We're just going to check if we can ping our ISP. What was this? The 20, let's do the 30, 255, the 4, 2. Connected here. Now we should ping our 8.8.8. Here we have it. We can ping this one, and we can ping this one. A question: what would happen if our router 1 were to say to encounter a failure? For example, gigabit 00 is cut, the cable is cut. What would happen? Let's try to ping again, and we have a timeout. It's not connected because our default gateway is that 10.0.0.3. Remember, we can only use one default gateway for this IP, especially IPv4. So how can we remedy this? Well, of course, we are going to use HSRP. Amazing. So we're going to reconnect it with this. Double check. Say run now. Since we are going to administer one default gateway, we're going to say right now this IP address should be will become our virtual IP address. Imagine this as a virtual router that is administered by R1 or R2 or R3, R4, R5, R6, and so on and so forth. Now, because of that, I'm going to change the default gateway. 1. This one as well. Now, if I ping 888, what will happen? It won't work because I haven't configured HSRP yet. So let's start configuring HSRP. So how do you configure the HSRP? Well, you're going to configure actually the interface that's connected to the network. In our case, it's the physical interface gigabit 00, but you can also configure interfaces like VLANs, which I haven't done right now. So we're going to stick with interface gigabit 00. You may encounter configuring interfaces in VLANs, however, because that's what companies like using virtual local area networks. So here we have it. What's the command for HSRP? It's standby. What is 1? That's a group ID. It must be the same across all networks using the same default gateway. So in router 1 and router 2, we'll be using standby 1 with an IP auth, or we're going to initiate. Actually, let me show you. This is the options. This is for IPv4 and IPv6. We're going to enable HSRP of IPv4, and we're going to add the virtual IP address, or what we'll be using as a default gateway. So it's 10.0.0.1. Okay, it's now enabled, but we're still not yet finished. Actually, I might just show you. Do show standby. Do show standby. We are standby. We are. See, right now we are in speak mode. We have your group 1. The priority is 100. The default. We are now speaking. Active is unknown. Standby is unknown. But we already have our virtual IP. Now then, let's start. Standby 1. Group, then preempt. What does preempt do? Okay, let's show what does preempt do. Preempt is overthrow lower priority active routers. So anything that's lower than our priority, we're going to overthrow them. We're going to make them non-existent. We don't care about that. Let's do this again. See, this command made our router instantly active. So that's what you do when you want your main router to be active pronto. Now we're going to add a priority as well for testing. 150. So to show, yep, we still don't have a standby unknown. That's okay, which we're going to add one right now. Do the same with this one. Now what if I do both preamp? Yeah, there's going to be a communication error. They will both fight for each other. However, if the priority is still higher in R1 will still become the active. They will think they're the active actually, if you keep using preamp. So just a heads up, don't use preamp. Just use it once in one router, just to make it just the startup of any program, of any loop actually. So standby, what's the next? What's standby group? 1. And the IP, what's the default gateway that we're going to use? Then that's 0.1. And last but not the least, by the way, HSRP is Cisco proprietary. Cisco is the only one that has it. There is also VRF and GBLP. We're going to discuss it later. We're going to add a priority, which 100, and show standby BRF. There we have it. Usually you need to restart them over and over again to show which one, if we are already show standby. But in our case right now, it was fast. Usually you have to wait. There we have it. You are now configured with your HSRP. Now let's testing it again. We should be able to ping 888 both routers. Yeah, I made a mistake about that one, but yeah. See? Ping 8.8.8 and running. Now what if we are to close this one? We can ping that, right? But we are still able to ping this. That's not full of shit. Show IP interface. Show. I just disconnected. This should. It still runs. That's the. It's a ugly example. That shouldn't happen. My bad. I'm gonna delete this one though. And because of that, aha! Now R2 is our linked local. Something is wrong. It's still trying to become the IP. Let's try pinging. You can still ping that. I think I know what happened again. I'm this. So I should be able to ping. Yep, I'm still able to ping this. You are having an error. See? I can still ping that. Let's return this.
Are you going to eat or not?
Sure, I'm going to eat. Sige na.
Mag-init lang kung noon.
Once again, let's check the show. I'm again standby. So it worked.
Na lang kita. Diyan ka na lang kumain. Gusto mo? Gusto mo palang ulam. Yung kagabi, yung sinabawan o yung sardinas na niluto natin.
Sige, sardinas na. So that's about it. There's some faders, but we should be able to ping. There's an error here actually. So let's cut it again. But they are still pinging each other, I think. So I think that's why. Yeah. That's not the proper way to do it. So we're going just to do this. Connect Wrong one. Connect this one here. And what I'm going to do is to manually, let's say gigabit internet really is down, so shut it down. Connectivity interface. Shut and show IP interface PR. It's now shut down. Show standby by brief. Unknown, because it's down. This must be it. Then this must. Yep, there we go. It works. I should have cut it. There are some limitations in GNS3 because it is just a simulation, but that's what should happen. Whenever this is cut, the router should say this is administratively down. Of course, it won't work, and I'm going to run here, and to this ISP. So that's where it is. Same here, still works. So if we're going to turn it on again, push it, and this should still work. And yep, this one is active again. So that's all about HSRP. Thank you for watching GNS3 bite-sized videos. Oops, I'm gonna turn this off first.